Even Steven is a wonderful lesson that I use almost every year when I teach probability and intermediate mathematics. This lesson has many strengths. In this video, I would like to highlight two: how it uses the element of surprise to draw the student in, and the pattern that emerges in part two. Before we get to that, I would like you to engage with the opening problem as a student would. Even Steven is a two-player game of chance where players take turns drawing two tiles from a bag. If the two drawn tiles are the same color, player 1 gets a point. Otherwise, player 2 gets a point. A game is comprised of 20 draws. There are three versions of the game represented on the screen, which, if any, result in both players having equal chances of winning. Pause the video to think about your prediction. Resume viewing when you are ready. I have used this lesson many times, and the results at this stage are almost always the same. The vast majority of students choose version 2 as the only fair version because it has equal numbers of red and blue tiles. When asked to choose a least fair version of the game, students almost always choose version 3 because of the greater difference between the number of red and blue tiles. When we list and analyze the possible outcomes for the three versions, students are often surprised to find that version 2 is actually unfair and that version 3 is fair, and they want to know why this is so. This combination of surprise and wonder leads to increased engagement and greater learning. So let's take a look at those. As we can see, equal numbers of red and blue tiles in version 2 create more different color pairs, 1, 2, 3, 4, than same color pairs, 1, 2. So this game is not fair. In order to create equal numbers of same and different color pairs, you actually need the 3-to-1 ratio of version 3. We can see that with 1 red and 3 blue, we get 3 pairs of blues and 3 pairs comprised of red and blue. The other thing I like about this lesson is the pattern that emerges. The second part of Even Steven asks students to create a fair version of the game that uses 3 colors of tiles. Often, the added rigor of a third color will cause students to revert to their former thinking that equal numbers of tiles of each color will work. They should be guided to build upon the 1-to-3 ratio that worked in part 1. How many yellow tiles would you add to the 1 red and 3 blue to create a fair 3-color version of Even Steven? Pause the video while you make your prediction, then resume when you are ready. It turns out that you would need 9 new tiles. So let's see what that looks like. If the 1-to-3 ratio worked in part 1, then it stands to reason that it would work again with the introduction of a new color. The ratio for the 3-color game is 1 to 3 to 9. And I'll just type that in here. 1 to 3 to 9. The addition of this new information makes the pattern clear. Every time you add a new color of tile, you multiply the previous color's number of tiles by 3 to get the number of tiles that you will need. So with this pattern, students can create fair versions of Even Steven for any number of colors quite easily. So for example, if we were to add green tiles, we could just interpret the pattern and extend the pattern to say that we need 27 tiles of that color. This knowledge provides us, the students, with a lot of power to create endless versions of this game.